Jai Hind to all the students. Today, in the previous lecture, I told you all about what is Hadoop and basic introduction of Hadoop. Let's revise a few points before we proceed further. Out of which, the first one was that Hadoop was an open source framework that allows for the distributed processing of large data sets across clusters of computers using simple programming models. It is designed to scale up from a single server to thousands of machines, each offering local computation and storage. Hadoop has two main components. The first one is Hadoop Distributed File System or HDFS. This is the storage unit. It splits large data files into blocks and distributes them across the cluster. Second one is MapReduce. This is the processing unit. It processes the data in parallel, making it super efficient for big data tasks. It is used in various applications like data warehousing, log processing, recommendation systems and more. Now, the history of Hadoop, as I already told you, it began in 2002 with the Apache Nudge project, which aimed to build a web search engine that could crawl and index websites. Now, there were two people, Doug Cutting and Mike Caffarella. The developers behind the Nudge realized that project was too expensive to scale for indexing billions of web page. The HDFS is the cornerstone of the Hadoop ecosystem. It allows for the storage and management of large data sets across multiple machines in a distributed environment. These were some features of HDFS: scalability, fault tolerance, high throughput, data locality, write once, read many, and large data sets. If you still are not aware of these features, I already explained them in the previous lecture. You can study it from there. Now, HDFS architecture contains three parts. First one is name node, data nodes and secondary name node. What were these three parts? Name node is the master node that manages the metadata and namespace. It knows the file locations within the HDFS. Data nodes is the slave node that store the actual data blocks. They are responsible for serving read and write requests from clients. Secondary name node is not a backup but assists the primary name node in managing the metadata by taking periodic snapshots. Now, this is how the data flow happens in HDFS. Number one is the write operation. The client contacts the name node for metadata. Name node provides a list of data nodes to store the data. Client writes data directly to the data nodes. In the read operation, the client contacts the name node for metadata. Name node provides the list of data nodes where the data is stored. Client reads directly from the data nodes. Hadoop is a powerful ecosystem consisting of several components, each designed to handle different aspects of big data processing and storage. Here are the main components. Core components of Hadoop are Hadoop Distributed File System. The role of HDFS is to divide large files into blocks and distribute them across nodes in a cluster, ensuring fault tolerance and high throughput. MapReduce, the role of MapReduce is to enable processing of large data sets in parallel. Function of MapReduce is to split the job into map and reduce tasks, processing data close to where it is stored and optimizing performance. Ecosystem components of Hadoop is Yarn, yet another resource negotiator. Role of Yarn is to manage and schedule resources. Function of Yarn is to allocate system resources to various applications running in a Hadoop cluster, ensuring efficient data processing. Hadoop Common has a role to provide shared utilities and libraries. Function that contains the common Java libraries and utilities needed by other Hadoop modules. Data ingestion tools of Hadoop are Scoop. The role of Scoop is to facilitate data transfer. Function of Scoop is to transfer bulk data between Hadoop and relational databases. Another type of data ingestion tool is Flume. The role of Flume is to collect and transport log data. Function of Flume is to ingest streaming data into Hadoop for processing. Now these are some data processing tools: Hive, Pig. Hive is a data warehousing and SQL like querying tool, and the function of Hive is to provide a SQL interface for querying data stored in HDFS. Similarly, Pig performs the role of high level data processing, and function of Pig is to use a scripting language called Pig Latin for writing data analysis programs. Now data storage tools are: first one is HBase. The role of HBase is non-relational distributed database. Function of HBase is to store large amounts of sparse data and provide random real-time function read-write access. Another type of data storage tool is Cassandra. Role of Cassandra is to distributed NoSQL database. Function of Cassandra is to manage large amounts of structured data across many commodity servers without a single point of failure. Now these are some data serialization and coordination tools. The first one is Avro. Role of Avro is to do data serialization framework. Function of Avro is to provide data serialization and data exchange services for Hadoop. Zookeeper, the role of Zookeeper is to perform coordination services. Function of Zookeeper is to manage distributed applications by providing services like configuration management and synchronization. Now these are data analysis and visualization tools: Mout and Uzi. The role of Mout is it is a machine learning library. The function of Mout is providing scalable machine learning algorithms for clustering, classification and collaborative filtering. Similarly, Uzi performs the role of workflow scheduler. Function of Uzi is to manage Hadoop jobs as directed acyclic graphs of actions. Role of Ambari is cluster management. Function of Ambari is to simplify provisioning, managing and monitoring of Hadoop clusters. In the Hadoop ecosystem, data formats play a crucial role in storing, processing and managing large data sets efficiently. Here are some common data formats which are used in Hadoop. Text formats. Text formats contain plain text. Description, simple text files with new lines separated records. Usage, easy to read and write but not space efficient and lacks schema information. CSV or comma separated values. The description of CSV is text files with comma separated values. Usage of text CSV is widely used for tabular data but can have issues with delimiters within fields. Binary formats. Binary format has a sequence file description. Binary format for storing key value pairs. Usage efficient for map reduce input output, supports compression. Avro, description data serialization system that uses JSON for defining schemas and binary format for serialization. Usage of Avro is that it supports schema evolution and is used for data exchange between programs. Now Parquet is a columnar storage format. Usage is efficient for analytics, supports complex nested data structures and enables higher compression rates. ORC is optimized row columnar. Description of ORC is that it is a columnar storage format optimized for read performance. Usage is that it is commonly used for Hive provides high compression and fast query performance. Specialized formats or RC file, record columnar file. Description of RC file is that it combines row and columnar storage approaches. Usage is that it is used in Hive for better performance and than plain text formats. Thrift is a data serialization format that supports various programming languages. Usage is that it is used for remote procedure call and data serialization. Now, how will you choose the right format? If you want a text format, then it will be simple to use but it will be less efficient. Binary format will be more efficient but it will support compression and schema evolution. Columnar format is ideal for analytics and query performance. Each format has its strength and trade-offs. The choice depends on the specific use case such as the need for compression, schema evolution or query performance. Now, analyzing data with Hadoop involves several steps from data ingestion to processing and querying. Here is a high level overview of the process. Data ingestion. Before you can analyze data, you need to bring it into Hadoop ecosystem. Tools like Scoop and Flume are commonly used for this purpose. Scoop transfers data between Hadoop and relational database. Flume collects data and transports it into HDFS. Data storage. Once the data is ingested, it is stored in Hadoop distributed file system. HDFS provides reliable and scalable storage for large databases. Data processing. Hadoop offers several frameworks and tools for processing data. MapReduce, Hive, Pig, Spark are some of the data processing tools. Now, data querying. For analyzing and querying data, Hive enables SQL-like querying on large datasets stored in HDFS. Impala is a parallel processing SQL engine that provides low latency queries. Drill allows SQL querying on various data sources including HDFS and NoSQL databases. Data analysis. Hadoop provides tools for machine learning advanced analytics. Mount offers scalable machine learning algorithms for tasks like clustering, classification and collaborative filtering. MLib is a part of Apache Spark, a library for scalable machine learning including tools for classification, regression, clustering and collaborative filtering. Example workflow. Number 1, data ingestion. Use Scoop to import data from a relational database into HDFS. Second is data storage. Store the ingested data into HDFS. Third one is data processing. Use MapReduce or Spark to clean and transform the data. Fourth is data querying. Query the processed data using Hive or Impala. Fifth one is data analysis. Apply machine learning algorithm using Mount or MLib. Now, visualization. For visualizing the results, you can use tools like Hue, a web-based interface for Hadoop that includes tools for querying and visualizing data. Tableau connects to Hadoop and provides powerful data visualization capabilities. Real world example. Imagine you have a large data set of user behavior logs from a website. Here is how you might analyze this data with Hadoop. Number 1 is to ingest the logs. Use Flume to collect and store the logs in HDFS. Number 2 is store the data. Store the logs in HDFS for reliable and scalable storage. Number 3 is processing the data. Use Spark to clean and aggregate the logs, identifying trends and patterns in user behavior. Number 4 is query the data. Use Hive to perform ad hoc queries and generate reports on user engagement metrics. Number 5 is analyze the data. Use Mount to build a recommendation system based on the user behavior patterns. 6th one is visualizing the data. Use Tableau to create dashboards and visualization of user engagement and recommendations. Now, these are some steps to analyze data with Hadoop. First one is set up Hadoop. Install Hadoop on your cluster. You can use Apache Hadoop distribution or cloud-based solution like Amazon EMR. Number 2 is upload data to HDFS. Use the HDFS DFS to put command to transfer your data into HDFS. Number 3 is write MapReduce jobs. Develop your MapReduce programs in languages like Java, Python or Scala. Fourth one is execute jobs. Run your MapReduce jobs on Hadoop cluster using the Hadoop jar command. Number 5 is retrieve results. After the jobs complete, use the HDFS DFS get command to download the result from HDFS to use to your local machine. Number 6 is analyzing results. Use tools like Apache, Hive, Pig or HBase to perform further analysis and visualization. Now, what are the tools to? Now, these are some tools to enhance Hadoop data analysis. Hive, a data warehouse infrastructure, it provides data summarization and ad hoc querying. Pig, a high-level platform for creating MapReduce programs with a scripting language called Pig Latin. HBase, a distributed scalable big data store that can host very large tables with billions of rows and millions of columns. Spark, an alternative to MapReduce that offers faster data processing and supports SQL streaming data and complex analytics. Hadoop's ecosystem is vast and continuously evolving, providing various tools and techniques to enhance data analysis. Scaling out or horizontal scaling involves adding more machines or nodes to your existing Hadoop cluster to handle increased load or to process large dataset. This approach is preferred in big data environments like Hadoop since it allows you to achieve higher performance and fault tolerance without the need to invest in more powerful and often more expensive hardware. Steps to scale out Hadoop. Number 1 is to evaluate needs. Determine why you need to scale out, be it for increased data volume, high processing speed, or better fault tolerance. Number 2 is to add nodes physically or virtually. Add more machines to your cluster. Ensure they have compatible configurations with the existing node. Update configurations. HDFS, update the Hadoop configuration file to include the new nodes. Yarn, update the Yarn resource manager configuration to recognize the additional resources. Number 4 is to deploy Hadoop. Install and configure Hadoop on the new nodes, ensuring they are properly set up with the SSH access, Java and other dependencies. Rebalance HDFS. Use the HDFS balancer command to distribute data evenly across the new and existing nodes. Monitor cluster. Hadoop's monitoring tools like Ambari, Cloud Error Manager or Ganglia to ensure that the new nodes are functioning correctly and distributing to the cluster's performance. Hadoop benefits of scaling out. What happens if we scale out? What are the benefits? The first one is to enhance performance. It distributes the workload across more machines, reducing processing time. Second one is fault tolerance. More needs mean better data replication and fault tolerance. Third one is cost effectiveness. Generally cheaper to add more commodity hardware than upgrading existing nodes to more powerful machines. Then the fourth benefit of scaling out is the flexibility. It is easier to manage and adapt to changing data processing needs by adding or removing nodes as required. Now there are some tools for efficient scaling. The first one is Apache Ambari. It simplifies Hadoop cluster management by providing an easy to use interface for monitoring, configuration and scaling. Second is Cloud Error Manager. It offers a comprehensive suite for Hadoop management, including tools for adding nodes and managing cluster performance. Third one is Ganglia, a scalable and distributed monitoring system for high performance computing systems like Hadoop cluster. Scaling out ensures that your Hadoop cluster can handle growing data needs while maintaining performance and reliability. Now, Hadoop streaming is a powerful utility that allows you to create and run MapReduce jobs with any executable or script as a mapper and a reducer. This is especially useful if you want to leverage languages other than Java such as Python, Ruby, etc. for your Hadoop jobs. Here is a step-by-step guide on using Hadoop streaming. Prepare your data. Ensure that your input data is in a format that mapper can process. Hadoop typically expects text files with one record per line. Second step is to write your mapper and reducer. You can write your mapper and reducer in any language. Here is a simple example using Python. Third step is make scripts executable. Make sure your scripts are executable. chmod plus x mapper.py.reducer.py. Run the Hadoop streaming job. Use the Hadoop jar command to run your streaming job. Here is an example of the command. You can read the command from this on your screen. The fifth step is to check the output. Once the job is complete, check the output directory specified in the command. Results will be stored in part 0000 files. Example use cases. First one is log processing, analyzing server logs, filtering specific entries, etc. Then comes text processing, word count, frequency analysis, etc. Third one is data transformation, converting data formats, filtering records, etc. Now Hadoop streaming is very versatile and allows you to integrate your existing scripts into the Hadoop ecosystem, making it a valuable tool for big data processing. Now what are Hadoop pipes? Hadoop pipes is a C++ library that allows you to write MapReduce programs in C++. It provides an interface for Hadoop to execute C++ code within the Hadoop framework. This can be useful if you are more comfortable with C++ or if you have existing C++ code that you would like to integrate into your Hadoop workflows. Now, these are some of the steps to use Hadoop pipes. First one is to set up the environment. Ensure that Hadoop is installed and configured on your cluster. Second is to install a C++ compiler like GCC if it is not already installed. Second step is to write your mapper and reducer in C++. Here is an example of a simple word count program using Hadoop pipes. Now you can, I have already written down the program on the screen. You can read it from here. So this will be all for today. I will be continuing the further in the next lecture, like what are the benefits of Hadoop pipes, right? So thank you so much.